Okay guys, this video is a question. Can this panel, 10 watts, run these 4 pumps independently? All by itself with no battery, no external power. This is what this panel kind of looks like. You know these pumps. We've talked about it in the previous video. The panel's not much bigger than the 5 watt panel. It's not much bigger. So let's give it a try. Direct sun. All 4 pumps cranking it out non-stop on a bright sunny day. If you get that thing lined up right, you're golden, man. There's no pausing at all. Those pumps are all going full bore. Wow. Yeah, so there's potential. If you had some kind of tracker on that baby, oh my gosh. You could stay in the direct sun on a hot day, and I think it would definitely provide some bubbles to your tank. Most of these are wide open. I'm not really trying to restrict the airflow and get micro bubbles at this point. I'm just seeing if they work. And indeed they do. So let's see how these are wired here. I'll make a diagram so you can better see what's going on. Okay guys, here's what our schematic looks like. We have an 18 volt panel. We can't supply these pumps P1, 2, 3, and 4 with 18 volts direct because it might damage the pump. The pumps are only rated for 12 volts. Therefore, we're going to put them in parallel. It's still going to have 18 volts going down each track, but each pump is going to consume half of that, more or less. So 9 volts are dropped after the first pump, and then 9 volts are consumed after the second pump. And on the other track, again, because we have them in series, 2 in series on each track, we're able to split that voltage in half and not damage the pumps. And the pumps can run it down at 9 volts, 10 volts, no problem, as we've seen with this setup. Now, in terms of amps, that's a little different. So in amps, remember amps, when they go down to parallel tracks, the current actually divides. So if our panels are giving us 0.35 or maybe up to 0.4 amps, just to round it up, we're going to get 0.2 amps in each parallel path here. Okay, this is how you don't want to wire them. You don't want to just go right into the main cable, split them all 4 equally, because the 18 volts will go down each parallel path, and because the rated wattage is only 12 volts, I don't know if it can go higher. I'm afraid if you go 18, you might destroy your pump, and you might get too low of current because it is split. Remember, current gets split on parallel tracks, voltage does not. So this is not the setup you want. You want this setup. Oh, before we move on, just a side note, you might say, gosh, those pumps are rated for 0.35 amps. Why in the world are they only consuming 0.2? What happens is the velocity increases as the flow of water goes through this narrowing, and due to Bernoulli's principle, if velocity increases, pressure will decrease. Okay, so this area has decreased pressure. Well, when you have decreased pressure, you get a suction, like a vacuum cleaner, and you suck the air in, right? And then you get an air-water mixture that is lighter in density than water to push really against. But I think the main point is the decreased pressure means that the pump has to push less hard. So therefore it doesn't need to consume its maximum current to function. It can use the 0.2. Okay guys, here we are just seeing how much 4 pumps will draw. We're way below, at least according to my multimeter, the 0.56 amps max off that panel. We're getting a pretty steady 0.35. That's just crazy that such a low amount of current from a solar panel, such a low amount of current is able to drive those pumps so well. But if you don't have electricity where your bins are, this is definitely a viable option, at least to get some air during the most sunny time of the day, which is when your plants are going to scream for oxygen, and maybe this is the way to go. eco-worthy 10-watt panel. Oh my gosh, that's all you need to drive 4 pumps. I can't believe it. I'm really shocked myself. Okay guys, let's hook up these 4 pumps in real life, not just in a drawing. Remember, we talked about having 2 pathways, essentially 2 pathways in parallel, but each pathway will have 2 pumps in series. That way our 18 to 22 volts or whatever's coming out of the solar panel will be split in half between the 2 pumps on each pathway because they're in series. So electrons travel from the black, through the black, around here through the motor. They're still flowing this way back through this red wire. Even though it's red, it's going to hook up into this guy's black wire. Electrons keep flowing, and then we're talking about the current. The current drives this motor, and then it comes back to the solar panel through this red terminal. And the same thing happens in this track or this pathway, this other parallel pathway. Comes in through the black, hits the motor, current's moving through, comes down here, goes back to the other motor in series, comes back here. So what we really need to do is take the reds, hook it into the red of the solar panel, and the blacks, and hook that into the black of the solar panel. I hope that's clear. Let me try it. Okay, so I brought my solar panel over here, and remember it's got this extra extender, which is kind of nice, quick release. Okay, but you can see the solar panel has the red and black terminals. So like I said, I'm going to take the blacks from the 2 parallel pathway tracks with 2 pumps on each in series and put those onto the black, and likewise I'll do the same with the red. Did you see the blacks go together? This is probably temporary. I just need to get over there and see if it's going to fit, so I might have to add some wire length to some of these, since I'm going to try to run 4 at a time, 4 bins at a time. But you see I've got the blacks, and now I'm going to do the reds. I got the 3 reds connected, the 3 blacks connected to that solar panel. Remember that there's 2 pathways in parallel, and there's 2 pumps in each parallel pathway in series. So there's 4 pumps total. I think I'm going to put it down here because these 4 pumps fit better, a little tighter together off one panel. You see when I bring it up here and eventually plug it into something either there or there. I had these 2 independent dual pump units, but I'd like to get a quad pump unit. And I think I just put it right here to test it out. I'm just going to have to find a place on this fence that gets a lot of sun. I mean, these guys are cranking these dual units. So let me strip these wires a little bit, solder them together, and get them hooked up. Okay guys, you just get yourself a cheap soldering iron. Sometimes you can get some of these other add-on accessories. You can use a sponge, or you can get, I think that's a brass type tip cleaner here that you just go back and forth, get the thing clean, the tip clean, and then you got your solder and your helping hands if you need some help there. And then you just kind of wire them together and put some solder on it, and then pull your shrink wrap right over it. Once you got that shrink wrap on, you just hit it with a little hot air gun, or you can even use a flame just from a distance to warm it up, and it'll shrink right over that. So what I'm showing you is very easy. You don't even need to solder these together, these wires, these connectors. You can just use quick connectors. There's all sorts of them on Amazon. Or if you want to go the extra yard, just get a cheap soldering iron and kind of watch a few videos how to do it. It's really not that hard. You just put the solder iron onto the wire, warm it up, and after a few seconds you can take your solder and just kind of lay it on top, and it'll soak up into there. Not perfect, but it'll work. And then let's move on to this one, and we'll just kind of go down the line and try to get rid of some of these temporary caps I put on. Okay, that one's done too, so I slide this up, the shrink wrap over it, and then I just hit it real lightly with a heat gun, or if you don't have that, you can even use any source of heat like a candle. From a distance, the flame will just, not too close, you don't want to melt the the shrink wrap, or you can even use your soldering iron. Just lightly tap it until it seals down over that and makes a waterproof seal. And you know, when you're done, just hit this on the sponge, clean off your tip. Always try to keep your tip clean, and then just hit it with a little solder here, you know, to kind of wet it, you know, to kind of keep it nice and clean there. And make sure you don't burn yourself. They're hot, and then turn your power down until you're ready to use it again. Piece of cake, guys. You can do this if you've not done it before. Okay guys, here we are. I have this one solar panel hooked up to these 4 pumps. It's morning, so this is facing east. I'm going to put it on a pole and face it more south eventually, but you see it comes down. Remember, we wired it all together so that we had 2 tracks with 2 in series on each track. 2 parallel tracks with 2 on series. These are the first 2. And you can see they're all cranking out, and again, we're not in the strong sun of the day. We're just in the early morning sun, but I mean, oops, that one. Yeah, here we go. They're cranking. I'm just gonna leave these. The reason I flipped the lids here was when I tried to push those down with the clips the other way, they kind of made it difficult with these tubes coming out. Plus, I wanted to shed the rainwater, as you've seen in my previous video, by flipping the lid. So I painted them white on the back side here. Use some spray paint, some Rust-Oleum, high gloss, semi-gloss, and yeah, all 4 pumps just cranking away. And we're only on one little 10-watt solar panel from EcoWorthy. Thanks for watching, guys. Please like and subscribe. Hope you enjoy these videos. Have a great day. Bye.